So this video is a short note about reduced row echelon forms and row echelon forms, and I'm asking essentially whether these forms are unique for a given matrix. So we'll start with the row echelon form, and I'll show you what I mean with the following example. So I've got a matrix 1, 2, 1, 1, okay, given here. You don't need to think that it's related to a linear system. That's not the point here. I just think that you have an array of numbers, okay, stored in a matrix, and I want to know if by performing row operations on it, I will always end up, no matter what I do, with the same row echelon form. Now there's a precise recipe, right, that I can apply, which is Gaussian elimination. So maybe let's do that first. So if I use Gaussian elimination, let's see what we get. What I want to do is introduce a leading one here, but it's already there. And then after that, I want to place a 0 below it. So to do that, I will do row 2 minus row 1. Right? I subtract a multiple of the line with a leading 1. So doing that, I'm going to get this. And after that, I will want to bring a leading 1 here. So how do I do that? I just do minus row 2, right? I multiply row 2 by a multiple that will make this entry a 1. And now I'm essentially done. I've got a matrix in row echelon form. So Gaussian elimination does that. I get this matrix in row echelon form. So the question is, if let's say I don't follow these specific steps okay, that are given by Gaussian elimination, let's say I do other steps and eventually get a matrix in row echelon form, will it be also the matrix 1, 2, 0, 1? That's the question. So is 1, 2, 0, 1 unique in this case? So let's take a look. Another way. Here's another way of. I've got this. So instead, to bring, I will switch the rows. That's what I'll do. I'll switch row 2 with row 1. Look what happens. I've got this. Okay. Now I want to introduce a 0 here, so we'll do row 2 minus row 1. And doing that, I'm going to get 0 and 1. And now this is also in row echelon form. And if you compare to the form we had previously, they are not the same, right? Not equal. So this is a simple example that shows you that the row echelon form of a matrix is not unique. So the row echelon form of a matrix is not unique. And I've proved it with an example because I'm showing you an example where it's not unique. So if it were unique, it would be unique for all matrices. Well, here's a matrix where it's not unique, so that shows that that row echelon form is not always unique. How about the reduced row echelon form? Well, let's take a look at our matrix here. 1, 2, 1, 1. If I do so to put it in reduced row echelon form, I have to do Gauss-Jordan elimination. Well, Gauss-Jordan starts with first Gaussian elimination, so I won't redo all of my work. I've done it before, so Gaussian elimination gives me this, right? 1, 2, 0, 1. 1, 2, 0, 1. And then after that, I will want to bring a 0 here. I want to bring a 0 above, above the leading ones, above the columns that have leading ones, but in this case it's all the columns that have leading ones, and actually it's only the 2 that I need to replace by a 0 here to make it in reduced row echelon form. So I will do row 2 minus row minus 2 row 1, right? And doing that, I'm going to get a 1, 0, 0, 1. Like that, and I'm done. This is now in reduced row echelon form. And the question is, like, let's say I apply other row operations, okay? Another way, maybe. Another way, let's say I end up with this again. Then what could I do here? I'm going to try to break this and get some different reduced row echelon form. Can I do that? Let's say I do 2 row 2. I'm going to get this, and then maybe I do row 1 minus row 2. I get this. And then finally I do 1/2 of row 1 of row 2. I get that. So at least here I was not able to break it with my simple row operations. They're not very smart anyway. They kind of replicate what I've done here. But one thing I can't show you, but I can state, is that that reduced row echelon form is actually unique. So no matter what you do, okay, no matter if you try any other way to put it in reduced row echelon form, you're going to get exactly the same thing. So this we will not prove it. I will just accept the result. Okay, the reduced row echelon form of a matrix is unique. Okay. So let's take. So one thing that's true though. Okay, so about row echelon forms, even though it's not unique, is look at the 2 forms that I have there. I have 2 leading ones, right, in the same place. So that's always going to be true, though. And no matter how you end up with a matrix in row echelon form, you'll have the leading ones you'll have the same number of leading ones, and they will appear at the same place. So by that I mean that the leading ones will appear always in the same columns. So they'll have the same number of them, and they'll be located in the same columns. So let's take a look at a simple question. Question here. What are the possible row echelon form of the matrix A, B, C, D? So this is an arbitrary 2x2 matrix, and I want to know what are the possible row echelon form of that matrix. Now you'll probably want to put 1 somewhere, 1 somewhere, 0 somewhere, and numbers that could be anything. So you'll put stars for those. So try to answer that question and come back. So one way to sort this out is to look at the possible number of leading ones. So let's say there are 0 leading ones. What would be the row echelon form in that case? So there are 0 leading ones. It means that no row starts with a leading 1. That's essentially what it means. So that means that every row is a row of zeros, right? So that's the only possibility. Let's say I have 1 leading 1. Okay? It means that there's 1 row with a leading 1. Would it be in the first row or in the second row? Can't be in the second row, right? Because if it's in the second row, it means the first row would be all zeros, and we know that those rows of zeros are stacked at the bottom of the matrix. So it has to be there, which means that, well, then I have either the first non-zero occurs here, or it occurs here, and it has to be a 1. The first non-zero has to be a leading 1 if there's 1 leading 1. So if it occurs, let's look at this situation here. If it occurs here, it means that just before it's a 0. But if it occurs right at the beginning here, it means after that I could have any possible number. So I'll just put a star. Okay, so essentially you see that star here stands for, I could have that could be the row echelon form, or that, or or that. Okay, so the star means that it could be any number. Okay, and if there are two leading ones, maybe I shouldn't put them in the plural here. There's 1, there's 0, and 2 leading ones. 2 leading ones means that every row starts with a leading 1. So row 1 starts with a leading 1. It can't be there because that means row 2 would have its leading 1 there, and that's contradicting what the matrix in row echelon form would be, because below the leading 1 I have to have a 0. So I can't put the first leading 1, has to be here in the first column. Second one has to appear sort of diagonally with respect to the first one, so it has to be where I placed it. Here that has to be a 0, but this could be anything. And I'm kind of done because I've covered all possible cases. Okay, now let's try to answer the same question, but with reduced row echelon form. So what are the possible reduced row echelon form of A, B, C, D? So with the answers we have in our previous question, it should be easier to answer that question. So again, pause the video and try to answer it. So if you've got 0 leading ones, it's the same matrix as before. If you've got 1 leading 1, you're still in the situation where your leading 1 could be here or here, but and here that could still be anything. We're not contradicting the conditions for the matrix to be in reduced row echelon form. And if it has 2 leading ones, okay, this now is forced to be a 0 because the second column has a leading 1, so every other entry has to be a 0. That's the fourth condition for the matrix to be in reduced row echelon form. And that, I think we've got them all now, all the possibilities.